In this video, we are going to look at how to simplify trigonometric expressions using identities. So we've been verifying these trig identities, and we can see that there are any number of steps that we have to take, and we've seen that there's no one correct step at any given time. There are multiple steps we could take, and many of them could be correct. So what we're going to be doing in this video is essentially creating our own identities. We're going to start with a more complex trig expression, and we want to rewrite that expression in terms of the given trig function. So let's start with the example. Cosine x plus cotangent x times sine x over cotangent x. And I want to rewrite this using only the sine function. So that's not to say that there won't be numbers around it. It might be a 5 sine, or it might be a sine x plus 1 or a sine squared. But by the time I get to my answer, I only want to see the sine trig function. I don't want to see cosines, cotangents, any of those. And I want to write it in the simplest possible way. I want to simplify this as much as possible. So we know that we can always write cosines in terms of sines using the cofunction identities. We can write cotangents in terms of cosines and sines, and we just had cosines we can change. But I want to do it in the simplest way possible. So I'm going to work this out in a very similar fashion to how I did the trig verifications. I'm going to go about it the same way. It might help to write everything in terms of sine and cosine. That might be a good first step. It could help to break apart fractions. It could help to put fractions together. We're going to do all those same steps. And so what we found to be beneficial in the trig verifications was to write everything in terms of sine and cosine. So I'm going to start by doing that. I'm going to use my quotient identity on the numerator and my quotient identity on the denominator. Now I think it also would have been completely logical to have broken this up into two fractions, because we can see those cotangents are going to cancel if we split it up into two fractions. Now at this point I see some simplification. The signs here are actually canceling. So I have a cosine x plus cosine x over cosine x over sine x. Now I'll point out two things here. One, notice I didn't write an explanation next to it. If you want to just keep up the habit of writing those explanations, because we know we have to do that for the trig verifications, if you want to keep writing down what you use, and if that makes it easier to understand your work afterwards, go for it. But I am not going to require you to write out explanations, because these are different than the trig verifications. We are finding what it's equal to. We aren't given the solution at the beginning. We're figuring out what it's going to be equal to. And so our work is not improving anything. It is figuring out what we need to get to. So over here I'll put in blue brackets. These are optional. You do not need to write out these explanations. Now the other thing I wanted to point out is that it almost seems like we got further from the answer. We want to have everything in terms of sine, and yet we just cancel that out of sine. I'm not going to worry about that right now. I'm going to work to simplify this thing first. We'll do any conversions that we have to at the end. My next step, I can see that I have two cosines on the numerator, so I'm going to write that as 2 cosine x over the cosine x sine x. And if I want to keep writing out those explanations, here we added, sorry, I skipped one. Let me write this one in first. Here we canceled. We divided out those signs, and then we added. And again, these are not necessary, but I'm going to write them anyways. And now I see that I have a fraction and a fraction, and what we said when we were verifying our trig identities, we never want to see that. We want to simplify fractions within fractions, and we can do that by multiplying by the reciprocal. And now we see that the cosines will cancel. So we're left with the 2 sine x. Cancel, divide. And that's pretty simple, right? Compared to what we started with, that's a pretty simple expression. We only have sine left in it, and that's what we wanted to see. So we have 2 sine x, and that is our answer. Let's take another example. Let's say that we have sine to the 4th t minus cosine to the 4th t. And I want to see that this is written purely in terms of cosine t's. I've switched the variable just to prove that we can, but the instructions are the same. I want to write this complex expression purely in terms of the cosine function. So I'm going to start with something we've done quite a bit, which is to look at this and say, well, that definitely can be factored. I don't know how to change a sine to the 4th over to cosine to to some sort of cosine, but I know how to do it with cosines and sine squareds. I know how to go between those. So we can factor this as sine squared t plus cosine squared t, and then sine squared t minus cosine squared t. And if we want to write out those explanations, our line would be factor. Sine squared plus cosine squared, that's just equal to 1. And so we have 1 times sine squared t minus, forgot my t up here, minus cosine squared t. That's a Pythagorean identity. Next thing I can do is multiply these things together. 1 times is just itself, so we have sine squared t minus cosine squared t. So notice it's looking a lot more simple. It's a lot nicer of an expression, but I still need it to be purely in terms of cosines. Right now I have a sine squared. Well, I can very easily convert that over to 1 minus cosine squared using my my Pythagorean identity once again. It's a t. And so now at this point, we have 1 minus 2 cosine squared t just by subtracting those two things. And we have an expression. There's only cosine in it. I don't see any other way to clearly simplify this. Cosine squared we could change over to sine squared, but we don't want to do that. We want to have it in terms of cosine squared. So I'm done. This is as simple as I can go, and my answer is purely in terms of cosine. So notice we're using the exact same steps we did for our trig verifications. The only thing we've added into this is that we are unsure of where we're going to get to at the start. We know what we want to have it generally look like, but we're trying to essentially create our own trig verification. We're going to do one more, but I will just stress that the only reason that I am giving you what we want to have it written in terms of is because we could always write things multiple ways. So I could have written this in terms of sine too. So by writing that I want to have it in terms of cosine, it just standardizes all the answers. But we're creating our own trig functions. We're just making these things more simple. And then that given statement, that given trig function is just so we standardize all the answers so it's easier to make sure that we are on the right path. Let's take one more. Let's take 1 over 1 minus cosine of x minus cosine x over 1 plus x, 1 plus cosine x. And I want to write this one purely in terms of cosecant x. And so we have a different trig function yet again that we're trying to get to. We know that cosecant is just the reciprocal of sine. So in the back of my mind, I'm kind of holding in there that I'm looking for sines. That's really my goal. And so I'm going to see what I can do with these two things. I see that I have two different fractions. I'm going to go and add those fractions together by getting a common denominator. So the common denominator, we would have to multiply the 1 plus cosine x to the 1. And we'd have to multiply the cosine x by 1 minus cosine x. And that would give us the common denominator of 1 plus cosine x times 1 minus cosine x. Both of these elements were necessary in our common denominator. So I've multiplied them together in my denominator, and my numerators just needed the opposite piece. If we simplify what we have, we're going to have a 1 plus cosine x minus cosine x minus cosine squared x. And cosine minus cosine, this should have been a plus. That should be a 1 plus because those cosines are both double negative. But the cosines have opposite signs, so they will cancel. So we're going to have 1 plus cosine squared x over, and if we were to multiply out that denominator, we would have 1 minus cosine squared x. Now I can, if we're remembering what we're trying to get to, we're trying to get to a cosecant x. And I don't see any cosecants, but we said that they're in terms of sines, so it might help to write these things in terms of sines, because then at least we'll have an easier time using the reciprocal to get to the cosecant. The numerator is going to be a little bit more complex here, because we have to write it as the 1 minus sine squared. The denominator, that's pretty straightforward. That is just sine squared x. Right away we get to that answer. In the numerator, we can simplify that. 1 plus 1 is 2 minus sine squared x. And then the denominator, we haven't done anything to it. It's just sine squared x. And remember we can always break apart fractions across the denominator as long as there's just one element in the denominator. If this was reversed, we could not split it up. If there are more than two things in the denominator, we can't break apart a denominator. But I can break apart a numerator, so I can say this is 2 over sine squared x minus sine squared x over sine squared x. Of course, that's just equal to 1. But the important thing is now we've finally gotten that sine squared x in the denominator, so we know it can come up to the numerator as a cosecant. Because it was sine squared, it's going to be a cosecant squared. And then sine over sine is just a 1. And so now we have an expression. It's pretty simple. There's nothing else I can add, subtract, multiply very easily here. I have the desired trig function, the cosecant, and in this case it's a squared, but that's fine. It's purely written in terms of that one trig function. And we just have the numbers around it. So we're done. Notice on this one I didn't bother to write out any of those explanations. Like I said, I'm not usually going to request that on these types of problems because we don't have the answer given to us. We're seeking for what that answer is. We're looking for what it's supposed to give us. But we're using the exact same ideas that we used with the trig verifications. The only thing is we don't know what it is at the outset. We are developing that trig identity. We are seeing how can I go about using my identities? How can I add, subtract, multiply, divide, factor? How can I simplify to get this to a more simple answer given the trig function that was requested?